Okay, good afternoon. Right, so today we want to start the fourth topic, that is operating system. Okay, right. So I enable the operating system not in the Google Classroom. Uh, so introduction to OS, file handling, process management, and memory management. And this is one of the smallest topic in your A-level ICT, but it's a very important topic because you get some MCQs and also most of the time the question is in the structured essay paper. Right, structured essay paper, especially the memory management calculation questions they give. Most of the time they give calculation related to memory management. Okay, or sometimes theory question related to process and file management. Okay, right. So let's straight away start introduction to OS. But first, I will just show you the syllabus for this topic. Okay. We'll do few more logic questions, right? So while we are proceeding with memory, okay? Sorry, operating systems. So we did the third topic fully. Last time we did latches, okay? At topic 5, sorry, topic 5, not 4, uh, operating systems, okay? So introduction to computer operating systems, evolution of OS, main functions of an operating system, classification of operating systems like single user, single task, and so on. Then you have the file management, file types, directory and file organizations, file systems, file security, and so on, defragmentation. So that is file management. So then you have the process management, okay? And then you have the memory management, okay? Memory management. So then operating system topic is over. Right, so first we'll start with little bit of introduction to operating system and classifications and bit of history of operating systems, okay? Evolution of OS, classifications, and major task of OSs, okay? Right. 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 So remember, we can subdivide or we can understand computer system using layered architecture. So that is something we discuss in sort of the very first day when we discuss introduction to computer. So we can understand computer using the layered architecture. That is the most effective approach. So we can think of it as, let's set of layers. Lower layer has support the upper layer. Okay. So therefore hardware is there. On top of hardware, we have firmware, which is theoretically anyway software, but more related to running the hardware. So then you have the software, which we can subdivide into a system software and application software. Then of course the users, so the liveware. So what is the difference between system software and application software? So application softwares are the different applications, personal or business, like order processing system, inventory management system, maybe in business context, or maybe in personal context, something like address management system, like graphic editing system, and so on, or for personal appointment management system, and so on. So then you have the system software, and we know that system software is uh, can be subdivided into 3 categories or 3 type of 3 components. That is basically uh, operating system. That is the main part of the system software. So then system utilities like file compression software, some security utilities, and so on, network utilities, and system translators like compilers, interpreters. So those system software help converting your source code into machine code and execute it. So what are the 3 components of system software? Operating system, system translators, system utilities. So operating system is our topic. So therefore, you know that operating system is one of the, or we can say the major system software. Major system software. Okay. So basically, operating system sit in between application and firmware because it's a system software, operating system, and help operate your computer system. That is why we say operating system. So basically, operating system is the main software in your computer. Major software. Okay. Right. So let's look at little bit of evolution of operating system. So you know that computers, especially the electronic computers, evolved in 1940s, 50s, right, 60s, up to now. If you take something like 1940s, 50s, most of the computer, not most, almost all those computers or computing devices were able to do single task. Or most of the time, actually, those computers were designed to do one task. Those were not general purpose. So one computer, maybe to do some specific calculation or some other specific usage. And also they used to run only one program at a time because those are single task computers like our blender, washing machine. At a time you wash one set of clothes. At a time you blend one set of materials. So there's nothing called you do two things at the same time using your blender. Of course, now you have some sophisticated blenders where maybe you can do both mixing and grinding at the same time. But otherwise, it's single task. So the computers were also single tasks. Right? At a time, only one task is done. Obviously, because mostly the computers were made to do single tasks at that time. Of course, at that time, when the computer was a single task, there was no need of OS because we just run that task when we need. Things were very simple. So then came the general purpose computers, not single task computers. So that is computer capable of doing multiple things. So that is where the computer became more complicated because it is not doing one thing like a washing machine, okay, or iron. It is capable of doing multiple things. When you have multiple things, of course, you need multiple software. Multiple software. So then these different software may need to access hardware differently. So that is where the need of operating system came. So we needed a special software that manage these other software and of course help using the hardware. So then came multitasking computers. Multitasking means at a time multiple tasks can be done. Right? At a time. So general purpose computer means basically maybe at different times you can run different programs. But what happens at the same time if you can run more than one programs? So that is where we call it multitasking computers. So the modern computers are multitasking. So I'm running Zoom, I'm running this particular software that I can draw in the screen. I'm running PowerPoint and there are so many other software running in the background. So that is multitasking computers. So when multitasking means multiple programs are run at the same time. So the need of operating system became more important. And now we have not only multitasking, multi-user multitasking computers. So that means at a time, your computer can run multiple programs. So that is multitasking. Not only that, at a time, multiple users can log into the system and use it, run programs. So just one computer, but there maybe 3 people running their programs in the same computer. So that is what is people multi-user multitasking. For example, when you use your smartphone, so that is obviously multitasking, but it's single user multitasking or just multitasking. So most of the time when you use your Windows, Mac computers, mostly they are single user multitasking. But there are operating systems that support multi-user multitasking as well. So multi-user multitasking means at a time, multiple users log into the same computer and run different programs. So that is multi-user multitasking, which make the need of operating system even more important. Because not only multi programs are running, those programs may belong to different users, and maybe different users can run the instances of the same program at the same time. Okay, right. So that is how the things evolved. Single task computers, general purpose computers, multitasking, multi-user multitasking. Okay. So from single task compute onwards, the need of operating system came into the picture, and its importance is getting higher and higher. I already explained you that the system software consists of operating system, system translators, and other system utilities. Okay. And now we are into the operating system. Right. So let's first understand what are the objectives of operating system, or what are the main tasks operating system can do for you. Right. So remember, under operating system, your next 3 subtopics are basically how to manage files, how to manage process, so that is managing the software, okay, and so on. So therefore, basically those are our rest of the topics, right? So what can your operating system do? Obviously, it manage your hardware, your processor, memory, SSD. So everything is controlled and managed by operating system. All the hardware is under the operating system control. So that is a big key task of operating system. The most important, one of the most important tasks. Manage the hardware. So let other programs use the hardware resources. So second use of operating system is operating system manage software. So you can use operating system to install a software, uninstall a software, upgrade a software. And of course, when you run a program, basically it is your operating system that run it. So we call running program as a process. So process management is part of the operating system. So then operating system manage your files. All your files in your Windows or Mac or Linux operating system, those are under the control of operating system. Right. Hardware, programs, running programs, and files. So remember, running program, another name for running program is process. Okay, process. And of course, the operating system provides the basic security like basic authentication, basic authorization, and virus detection. And finally, operating system provide you a user interface for you to interact with the operating system. So that is basically from one side you have, if you go to something like settings, so you are accessing the operating system. So through the operating system, you try to handle your hardware, right? Your security, your software, right? Add software, now remove software, basic security management. So this is basically my operating system. It's interface. So it provides you the interface to handle your hardware, handle your files, handle your software. Okay, handle your software. So therefore, operating system manage hardware, manage software, not only install and uninstall, even running. So the running software is called process. Manage files, provide basic security and other UI for you to do user management, security management, file management, and so on. Okay. So you must not have any doubt about the usages. Right. So now we move on to the classification of operating systems. The common classification is single user, single task, OSS, single user multitask OSS, multi-user multitask OSS, and finally, special OS. There's a special type of OS called real-time OS. Right. So let's take one by one category by one. Single user, single task operating systems. Single user, single task OS means at a time your OS can run only one program, and of course at a time only one user can use it. So that means at a time only one user can log into the system, not more than one user at the same time. So of course different time, yes. So when one user log off, different user can log in, but that is not single. That is not multi user. It is single user. Single user means at a time only one user can log in and use. And of course, that user can do only one task at a time or run one program at a time. So then only we say single user, single task. For example, Windows is pretty much single user, but we can use it as a multi-user as well, but definitely it is multitask. So each window is one task. I can run Word, Photoshop, right? Calculator, browser at the same time. So the famous single-use, single-task OSs are basically command line computers like OSs like IBM, PC-DOS, and Microsoft MS-DOS. And Apple also had a DOS operating system. So those are basically command line OSs. Not only command line, when you now remember, even when you with your Windows, you have command lines, okay? But that is just a leftover from DOS. So it doesn't mean that Windows is single user, single task. Of course, here I can do one thing and then do another thing, do another thing. But I can open multiple command line and sort of parallelly do things as well. But early days of operating systems, when you switch on your computer, early days of operating systems, 1960s, 70s, 80s, when you switch on your computer, it boot up and give you a command prompt. And in that command prompt, you can run different programs. So therefore, single user, single task. Okay. So mainly the command line OSs. It doesn't mean that all the command line OSs are single user, like Linux, Unix. So they also have command line versions, but they are not single use, single task. But definitely PC-DOS, MS-DOS, command line versions in 1980s were single user, single task. Right, next one is single user multitask. So single user multitask means very good example is Windows or Mac OS or any of your smartphones, only single user can log into the system at a time. So if you want to log into the system and if already there's a user, when you log in, the other user is forcefully log off. Single user can access the system at a time. But the single user can run multiple programs at the same time in different windows. So very good example is Microsoft Windows. It's predominantly single user multitask OS. But of course, we can configure it to be multi-user multitask as well. But by default, single user multitask. Right. Finally, we have multi-user multitask OS. So multi-user multitask means, say you have the OS computer, something like Linux, Unix OS is there. So then multiple users can connect to the system at the same time. Not only that, they can run different programs or the same programs parallelly in their respective user sessions, which are happening at the same time. And of course, they can run multiple tasks. They can run multiple programs at the same time. So then we say it's multi-user multitasking. Multiple users can log into the system at the same time, and those users can do different tasks at the same time. Right. So the famous example for multi-user multitask operating system is Linux and Unix. Right? Unix and Linux. So from the very beginning, those two operating systems, of course, the Linux came later, first came Unix. Those operating system happen to be single task. Sorry, multi-user multitasking. Even though those were command line. Sometimes that can be command line. Still, multiple command lines can be opened and multiple programs can be run. And different users can log into the same system by using other terminal servers. Because you need a dedicated screen. Okay, right. So that is what is known as multi-user multitasking OS. Right. So now we have discussed single-user single task, which is not practically a OS. Then multi-user single-user multitask, and finally we moved on to multi-user multitask. And the final category that we look at is, of course, there can be some more classifications, but this is a final classification or another category for OSs, that is real-time OS. So what is mean by real-time OS? Real-time OS means it operates in real time. So that means when you give a command, give a task, it operates and give you the results in no time. So we call them real-time OSs. Okay. So real-time OSs process in real time. You don't feel any delay. So therefore, real-time OSs have only some specific usages, like life support systems in ICUs, because your medical equipments need to respond in real time to different situations like sudden blood pressure drop and so on. And of course, real-time OSs can be used in special scientific and industrial machineries, because there are situations you need to process trillions of data. And missile guide system is another possible use of real time. Remember, missile guideline systems, they can change their path dynamically. Sometimes when there's a missile fired at you, so you guys fire another missile targeting that missile. So those systems need to take very quick decisions. So then air traffic control systems and some streaming servers like YouTube servers. So they use some sort of a real-time operating system. Right. So that is our major categorization: single user, single task, single user, multitask, multi-user, multitask, okay, and real time. So there's nothing called multi-user, single task. Okay? There's no such category. Right. So now let's look at what are the types of operating systems based on usage. Because we can categorize operating systems in different way, like operating system belong to X company, Y company, Z company, and so on. Right. So this is classification of OSs based on the use. This is different. Of course, we use operating systems in our PCs, laptops, notepads. So that is one use of for one category of operating systems, targeting those machines. But there are some operating systems targeting for operating servers. Basically, servers are nothing but high-end computers with higher time time slots, higher response, and so on. Okay, right. For example, for personal computer operating systems are very famous things: Windows, Apple, Mac, even Ubuntu, something like a Linux operating system. So those are all what OSs for personal computers. So then we have operating system for servers. So those are a little bit more serious, more secure, more performance operating systems. Like Linux for servers, like Red Hat Linux, Enterprise Linux. Even Windows has a server version, Windows Server version. So first we look at OSs for personal computing, PC, OSs for servers. So then there's another category called network operating systems. In a network environment, to overall manage the network, sometimes the network server is given a special operating system, which is a network operating system. But these days, the difference between network OS and normal OS is getting smaller and smaller. So then we have OSs for small devices like smartphones, tabs. Then there are OSs for other embedded devices like smartphones, smart washing machines, and so on. So there are some control actions. Okay. And of course, there are applications for real-time OSs like military applications or medical applications. Right. So these are the families of OSs. Families of OSs. So you may have heard some of these families and their members. Maybe you have not heard some others. Right. I'm pretty sure most of you guys are using a Windows OS. Of course, before Windows, we had DOS. And it's a proprietary Microsoft operating system. Then Apple Mac, another proprietary operating system from Apple. Then we have the Unix and Linux, old Unix and newer Linux. When it comes to Linux, it is free and open source software. Source code is available free of charge. So another family of operating systems are Chrome-based operating systems developed by Google. Very lightweight operating system, especially if you are a heavy user of network, computer, internet. Then, of course, with the smartphones, you have the Google Android, Apple iOS. So those are the two most popular right now. But about 5-10 years ago, we had something like a blueberry and so on. Right. So this is little bit of history of operating system. So some historical OSs. You don't have to memorize these things, but it's good to know these things for your confidence. Okay. Right. So remember in 1940s, 50s, right, so we had big computers like a house, room, big computers with vacuum tubes and so on. So then came, so Share OS, IBCs, OS 360, those are some big OSs. So then came OSs for mini computers in 1960s and 70s. And later OSs for personal computers and laptops. Like PC DOS, MS DOS, Apple DOS, Unix came for that to fulfill those requirements. And of course, there are some historical operating systems which we no longer use, like Symbian OS, BlackBerry OS. Right. So we'll take a small break and we'll take one by one some popular OSs and some important points. Okay. Right. So now it's 4:40. We'll be starting at 4:45. 4:46. Okay. Now it's 4:41. Okay, so let's continue with some of the operating systems. Now you know the classification like single user single task, single user multitask, multi-user multitask, real time. There's nothing called multi-user single task. Okay, so that is because it doesn't make sense, right? Multi-users, but one user can do only one task. So that is not practical. So then we look at some usages. So based on usages like normal, all days, uh, mainframe OSs, mini computer OSs, personal computer OSs like IBM, Mac OS, Microsoft, and so on. Then real-time OSs and network OSs. So let's take some of the popular operating systems. Obviously, the most popular is Microsoft Windows. So basically, Microsoft Windows is continuation of DOS, Microsoft DOS. So before 1.x, Windows 1.x, it was DOS. But then they came up with the user interface, graphical user interfaces, very primitive, and they call it Windows 1.1, 1.2, and so on. So then came 2, 3, then Windows 95, Windows 98, 2000 or Millennium, and then came the Windows XP, another very famous OS, then Vista 7, 8, 10, and so on. So the key advantages of Windows operating systems are user friendliness and support for large number of hardware. So Windows OS is mean for non-technical users to do their task quickly. And also another very important point is Windows OS work for a lot of hardware. But if you take something like Mac OS runs only on Mac computer. But Windows OS, most of the computers support. Okay, and a lot of user friendliness is there. So there are some disadvantages of Microsoft Windows as well, because Microsoft Windows is not for all purposes. So one of the issue is bit of security issues, but it is getting better and better now. It had very terrible track record in 1980s, 90s for security, but now things are getting much better because now OS has built-in security system like Defender. Okay. And of course, Windows is not the most efficient operating system because Windows is built for general users, right? General users. So therefore, it adds some fanciness and so on, which take a lot of resources. So therefore, Windows is not ideal for servers, web servers, database servers, or any other place where you need high performance. So Windows is better for our day-to-day usages like smartphones, tabs, laptops. So second one is Apple Mac. And Mac is more popular for its elegance, reliability, okay, superior graphic quality, superior sound quality, and so on. But the biggest issue is Mac OS runs only on Mac hardware. So that is not the case when it comes to Windows, Linux. So those that OS support different hardware architectures. But Mac OS runs on only Apple computers, or we can run it effectively in Apple computers. So then we have the Unix and Linux. So first came Unix, then came Linux. Actually, Unix is one of the most, right, sort of a very old operating system. And from the beginning, Unix operating system was built for serious usages, high performance, high security. Especially used as servers, web servers, database servers, and so on. And Unix operating system was written in C language. But then came the Linux. So the biggest difference between Unix and Linux is Unix is a proprietary operating system. So they don't give you the source code. You lack freedom. But Linux use pretty much the same philosophy as Unix, but they made it free and open source. So source code was also published so that anyone can change it. So the result is so many Linux variations, hundreds of Linux variations, because anyone can take that code base and maybe do some modifications and release it under some other brand. So that is why you have Ubuntu, Red Hat, Fedora, Kali, Linux, you name it. There are plenty of OSs, Linux-based OSs. Each OS has somewhat different functionalities because Linux code base is open source. And again, mainly we use Linux for servers, for personal computers. But there is a small niche market for Linux-based mobile OSs as well and IoTs. So as I told you, since Linux is open source, right, free and open source software, anyone can take the source code and modify and release separately. So that is why we have so many Linux flavors or Linux distros. So all those Linux OSs belong to three categories: Debian Linux, Fedora Linux, OpenSUSE Linux. So the Debian family has Ubuntu, Mint, Kali. Fedora family is pretty much Fedora and CentOS. Of course, now they have continued the CentOS. And then you have the OpenSUSE, which is pretty much separate version, right? Debian releases, Fedora releases, and OpenSUSE, and each release can have its subtypes. Right, so then you have the mobile OSs, smartphone specific OSs. So what are the three or the two major smartphone specific OSs? That is obviously Android and iOS. So that everyone must know. Android from Google, which is pretty much open source, but not 100% open source, not 100% free and open source, but fairly open source. Then, of course, we have iOS from Apple, which is sort of a highly closed operating system, not open as Android. It's pretty much proprietary OS from Mac. For smartphones. So then there are some old, outdated smartphone operating systems or mobile operating systems like Symbian OS, BlackBerry OS, and so on. But those are no longer used. Right. So that is a very gentle introduction to operating systems. Okay, operating systems. So any questions you are having? Okay. Right. So now we move on to different usages of OS. Different usages of OS. Okay. Right. So what are the major usages? File handling, process or program handling, memory handling, and then handle the hardware. So let's first move on to file handling. So that note is also available. That is the second note, file handling. So I told you this is very small topic. Okay, so we don't have to do a lot of things. Right. So now it's 6:57. We'll take another small break, and we'll be starting at 4:42, and then we'll finish the file handling part. Okay. So file handling is the easiest. No calculations, nothing. Okay. Right. We'll take a 4 minutes break, 5 minutes break. Right. So let's move on to file handling. So remember, we have only three subtopics: file handling, process handling, memory handling. Okay. Right. File handling is the easiest because it doesn't include any calculations. Okay. And it's very simple thing. And we all know that for computer, everything is a file. So when you install a software, it's install set of files. Even operating system itself is set of files. So that is why you have system32 folder. Right. So your programs are set of files, your data is stored in set of files. Even a database is ultimately set of files. So therefore, files are important not for both data handling as well as programs. Okay. And file handling is done by operating system. You don't need a separate software for that. Okay. Right. So there are different ways we can classify files. Of course, there are hundreds of ways, but these are some common types of files. So plain text files. Often you can open it in something like Notepad, Notepad++. So plain text means it doesn't add anything, just it save the things that you type. Save things that you type. So that is what is by plain text. So when you have plain text, you can open that file in a very even when you have a very basic tool. Okay. Only thing is it may not be very fancy, good looking, but for simple usages, plain text files are important. And more than anything, when you do programming, your source code files like your Python file, Java file, C files must be plain text file. Because otherwise, because those whatever we write inside the file is getting executed. So unless it is plain text, there will be some other meanings creep into your program, special characters and so on. So that is why we always use plain text editors when it comes to writing programs. So then you can have different files. We can use it that can be opened by different programs. So these are some popular plain text file editors like Notepad in Windows, Nano VI in Linux, Emacs, MacVim from macOS. So when you use these tools to edit a file, guaranteed you don't add any special characters. And mainly we use it for very simple usages like some list and so on, and more and more as source code files. So then of course we have some special file types like Word file, the spreadsheet documents like Excel, XLS, image and graphic files like PNG, JPEG, audio files, MP3, AVL, AVI, video files, these days MP4s. Then application specific files. So those can be opened by only those applications. For example, docx file can be opened using Microsoft Word. SVG files can be opened using something like Inkscape. Okay, so those file formats can be opened by one or two specific software. And then we have the executable files. That means you can run it. Right? When you install software, you heavily use executable files like exes. So then bat files also you can run using command line, bat file, .bat file. So plain text files and some special cases like Word, spreadsheet, image, audio, video, application specific, and of course the executable files, bat, exe files. So these are some examples, okay? So Word documents, if it is Microsoft Word, it is Word docx. But if it is something like LibreOffice or OpenOffice Writer, it is ODT. Similarly, if it is Windows or Office, Microsoft Office, the spreadsheet saved as XLS or XLSX. But if it is OpenOffice or LibreOffice, it is ODS, Open Document Spreadsheet. ODT is Open Document Text for Word documents. Then for images, of course, there are plenty of types like BMP, PNG, JPG. Remember BMP, PNG, JPG, GIF, those are all for raster images. But if you are really interested in other type of images, how do you call it? Raster images or bitmap images. Other type is called anyone? Because we discussed that under
Vector images.
which one? Can you repeat?
Vector images.
Yeah, vector images. So if it is a vector images, usually it is SVG. Okay, so we discussed that under representing data also. Right. So these are some special type of Word documents, spreadsheets, images, audio, video. So you just need that general idea. General idea, maybe some general file types. Very rarely they check that in A level, but that is good for your confidence. Like, for example, you must know that if you see MP3 file, that is audio, whereas MP4 is video. MP3, Wave, Windows Media, Audio, WMA, those are all audio. Then some other specific application specific files like PSD for Photoshop, CDR for CorelDRAW. And these are some examples of executable files that you can run. EXE, BAT, ISO, especially ISO is used for installations. Okay, right. So now you must have some basic idea about what is a file and how do you what are the categorization of files. Remember these files, file is a sort of a logical unit. Right? So basically file has set of related data, or when I say data, it can be even programs, okay? So if you have two software, maybe two different files, or two different set of files. Maybe you are having data in different files. But file is sort of abstraction or level where we can interact with it with the help of OS. So that is why you can create a file, delete a file, copy file, paste file, rename file. So operating system can understand the unit called file. But remember, these files persist in some sort of a storage. Maybe in your hard disk, maybe in your SSD, maybe in the pen drive, or maybe in CD. Okay. So how do we save, or how does operating system save a file? How does your operating system access file? So you need to have some sort of understanding about those. So when it comes to managing files, we call it file allocation, which is done by operating system. Right? How does your operating system persist your files or contents in the data secondary storage? So the main objectives are, when it comes to file allocation strategies by OS, so OS want to effectively use the disk space, not to waste the disk space. And also it want to make sure that the OS can fast access and update, delete, or retrieve data. as fast as possible, because otherwise users will face delays. Right. So what are the different file allocation methods? File allocation methods means how does your storage is allocated to file, particular file. So these are some usages: contiguous file allocation, link file allocation, index file allocation. Okay, so what are the three allocation methods? Contiguous file allocation, link file allocation, index file allocation. Okay. So let's take one by one. Let's take hard disk. Okay, hard disk, because hard disks are still very popular. Of course, very quickly SSDs will overcome will overrun hard disk when it comes to storages, but still hard disk are heavily used. So therefore, focus on how the files are allocated is more biased towards hard disk. How does your files are saved in hard disk? Okay, so that is our main focus, not the SSD or any other thing. So therefore, you must know a little bit about the hard disk as well that we discussed in your topic 2, right? Introduction to computer. So remember, your hard disk has set of disks. Each disk has something like tracks and sectors, and all these disks rotate at the same time, and there are read-write heads. Right? So we discussed those things. Okay. So in hard disk, the smallest unit that operating system can access and retrieve or delete or update is called disk block. Disk block. So that means if you take one disk like this, so at a time it can access this kind of a block. Maybe your file, that particular block has maybe 3 or 4 files, or maybe your file is in multiple blocks. But the smallest your operating system can load to the memory from hard disk was basically hard disk is a block. Sometimes you take a block which contains your file as well as some other files. Can't tell. You have no other option because the smallest unit you can access is a block. Sometimes in order to access a file, you need to load multiple blocks because that file is in multiple blocks. Maybe you need to load all 3 blocks. And as I told you, maybe that those 3 blocks have not only your file, some other files or part of some other files, but we are not interested in those parts. Okay. So therefore, we have blocks. So what is mean by contiguous file allocation to files? Or to files, how does your storage is allocated? One approach, one strategy is called contiguous allocation. Contiguous allocation means when you want to save or persist a file, so it allocate contiguous or consecutive blocks. Maybe this one, usually contiguous these blocks are in parallel this, not, so don't think that this is the contiguous of this one. So the contiguous of this block is the same location in the other disk, then another disk, because all these read write terms move together. So therefore, when you take access this block, parallelly you can access this block and this block without any rotations or any other movements. So therefore, if a file is too big, if it is not fit into this block, it put it into other parties put it into that, and so on. So that when you read, you can read the entire all set of blocks, related blocks together, which improve the performance. Okay. So remember, contiguous doesn't mean something like this. No, contiguous means, basically contiguous means uh, so contiguous means maybe here, then the rest of the stuff goes to the corresponding block in the other disk, corresponding block in the other disk, and so on. So those are called contiguous blocks. But as a logic, this is the reality, but as a logic, we can think of it as, if these are the blocks, maybe contiguous blocks are something like this. Okay, so that is something, the way we can look at it, contiguous file allocation. We allocate contiguous blocks to a particular file so that it can be easily accessed. The full file can be easily retrieved. Okay. Right. So contiguous file allocation. So this is how you look at it. This is how you look at it. Okay. Say these are some files. File name, tr, mail, list. And you can see that, so F is another file. Okay. You can see that these files are taking contiguous blocks. F is taking these two blocks. TR is taking these three blocks. Okay, let me draw it in different color. Maybe TR is taking these three blocks. Maybe mail is taking these contiguous blocks. And maybe another file is taking these blocks. You can see that those are allocated contiguous, consecutive blocks. Consecutive blocks, at least as a logic. But in reality, those are different tracks or different sectors, right? That your read-write heads can access sort of a parallelly. Okay. So sometimes they ask questions about these tables. Okay. And you can see that this is the file name. This is the start block. Start block is 0 and it takes 2 blocks. So therefore it's 0 and 1. So there's a file called count. So this tr file start at block number 14, yes, and it take 3 blocks, 14, 15, and 16. So they have given these kind of questions and ask you fill the rest of the stuff or something like that. And you can see mail file start at 19 block and it takes 6 blocks. 1, 2, 3, 4, 5, 6. I hope you can understand, right? So this is not rocket science. This is very simple. So this is how operating system keep track of the files. So it knows for a given file name, what is the first starting block and how many blocks you need to check. Okay. So that is called contiguous file allocation. So what are the advantages and disadvantages of using contiguous file allocation? So when you retrieve data, if you want to retrieve the entire file, it's very efficient because your file is in contiguous blocks. Okay. That is when you read the entire file. there are situations you almost all the time you need to read the entire file. So contiguous allocation is really handy approach. Okay. So that means without much of a movements in the hard disk, you can load the entire file or most of the file to the memory. So some disadvantages, practical disadvantages. Sometimes contiguous blocks may not available to you because after sometimes your disk blocks are quite a lot allocated. Right? Sometimes you delete. When you delete, of course, those some of the blocks are available. But after sometimes, maybe, especially when you try to save big files, you will find it difficult to get contiguous blocks available. So then you need to do some rearrangement of the blocks, which take a bit of time. Okay. And also when you insert data to a file, sometimes what happens? So say you have allocated 3 blocks and the next block and other things are allocated for another, but occupied by another file. Now, when you add more data records here, so now you don't have contiguous blocks available. So then either you have to violate contiguous allocation or you need to restructure and let these blocks move to some other place and take this block for this file's use. So likewise, in the background, operating system need to do some rearrangement of the blocks, which we are not aware as users, but those things happens in the middle, in the background, which is little bit of overhead as well. Right. So any questions on contiguous file allocation? That is, for a given file, operating system try to allocate consecutive or contiguous blocks, which can be really handy when you want, when most of the time you read the entire file, not just 1 or 2 record.
So,
Yes.
can you explain how fragmentation occurs?
How?
Can you explain how the fragmentation occurs?
Okay. Yeah. So this is how the fragmentation occurs. For example, now assume, so this is current usage of my disk. Okay. So let's say another file is now used. Right. Another file is used, something like this. It is allocated because it has to be allocated. We need to allocate block from the existing use free blocks. Maybe another one is allocated these 3. Okay. These 3. Okay. Now let's say we have another big file, file, and your operating system calculate that it needs at least 5 blocks. At least 5 blocks. Now what happens is you can see that there are no consecutive 5 blocks here right now. Earlier we had 1, 2, 3, 4, 5, but because of this file now there are no more 5 blocks free storages, consecutive blocks. So in this kind of a situation, one option is operating system can reallocate maybe these 2 blocks to somewhere here, and then you have 1, 2, 3, 4, 5, 6 consecutive blocks. So that means you need to first, now you want to save a file, but before saving the file, maybe this file you want to take it to some other place so that you have that consecutive 5 blocks. But that is not always possible because that will delay the file saving, because usually when you save something, the users expect quick response. So therefore, in that kind of a situation, sometimes what your operating system does is it violates the consecutive contiguous file allocation. So like say it needs 5, so maybe it save these 4, and maybe the other part, last part is saved here. Likewise, we try to preserve contiguous allocation as much as possible, but that is possible at early stages. But when your disk is somewhat filled, it needs to save things in multiple locations. Maybe now I have another need for 4 blocks. Maybe it will save in these 4. Now you can see that for same file, your data is in not consecutive blocks, but fragmented blocks. Fragmented blocks. So therefore, when you retrieve the data, if it is a hard disk, you need to do a lot of rotational things, read, write, head, arm movements, because you want to go from this to this, and maybe this to this. Sometimes the rest of the stuff is here. So then we say our hard disk is fragmented. Fragmented. Because when it comes to big files, those are not in always in consecutive blocks, rather they are in different locations. Of course, there are ways to keep track of what is your next block and so on. So then we say my hard disk is somewhat fragmented. So the solution is time to time defragment it. So doing that defragmentation when you want to save a file is not the ideal time, because there you are trying to save your file, and if you start doing defragmentation, your file save is going to be slower. So therefore, what your operating system does is time to time. Remember, say you are using a laptop, your operating system knows that maybe for the last 30 minutes, the user is not using it. This is idling. Or it can identify some patterns, maybe every day 10 p.m. to 5 a.m. Of course, the computer is on, but user is not using it. Maybe user is sleeping. So likewise, it knows what are the free times. So at that time, in the background, this defragmentation happens. Sometimes it happens maybe once in 3 days or once in a week. So these things are happening in the background. So then when you want to save another file, there's a lesser chance of need for going for different pages. But again, after sometimes, again, when you have more and more files, again, it does the defragmentation in the background. So that is what happens. So that is called defragmentation. About 10-15 years ago, we used to go to the hard disk and do the defragmentation as a user. We right click and say defragment. But these days, the operating systems are smart enough. So when they have idle time, they do those things in the background, defragmentation. For example, if I go to my hard disk, say settings, storage or something. So this is my C drive. Where is my D drive? For C drive, the defragmentation is less issue because it's in my case it's SSD. So this defragmentation is more important when it comes to hard disks. Okay, so let's see whether I can get to my hard disk. But these cases also they do certain defragmentation. Okay, let me search for defragmentation. You can see defragmentation. Right, so you can see here, this is my C drive, this is my D drive. Okay, in my case, both are solid state. Actually, I don't have hard disk at all. Both C and D are solid state. But let's see whether there are any defragmentation schedules. Maybe you can go and say, yes, you can see schedule optimization on. Schedule optimization means at schedule time, my disk is optimized, defragmented. Okay, so let's say change settings. You can see it's currently it is weekly. Currently it is weekly. That means once a week, my SSD is defragmented. That is what is meant by optimize. Okay. So what about my D? Yeah, that is also weekly. Okay, you can see. So those things are happening in the background, defragmentation. So therefore, we don't get into big issues these days because these things are happening in the background. Okay. Right. You can see here that the last time the defragmentation has happened in my laptop for both C and D, 6 days since last, right? Retrim. Okay, so retrim is pretty much defragmentation. So usually, most probably today or tomorrow, there will be another defragmentation because the frequency is once a week. Okay, so that is what is defragmentation. So once it fragmented, when we keep using, usually these days operating system does the defragmentation periodically. So that is reallocate these file blocks so that files get more and more consecutive blocks, more and more. Okay, more and more. But that is not required for all the files also. Sometimes files saved in different blocks is okay for some files. So therefore, this is little bit advanced topic, but we don't go into that kind of a very detailed understanding. Okay, because different file types have different requirements. For example, there are some file types we very rarely open the entire file. Most of the time, we just looking for one record, especially database files. So this contiguous file allocation is usually not required at all. Okay, so there are situations like that also. Okay, and I hope you got some idea, somewhat better idea about what is this fragmentation and so on. Okay, right. Right. So the next file allocation technique is second one is link file allocation. Link file allocation. In link file allocation, we are not very serious about allocating contiguous blocks for a particular file. Rather, we allocate a particular block and then another block may be somewhere else, but we create a link between this block and the new block. Like this block keep the address of the other block where the rest of the file is. So then we call it link file allocation because so this is called linked list in programming. It's something like this is linked to this and this is linked to this. This is for one file. Maybe for another file, we keep track of those. So we don't need those to be in the consecutive, then it is contiguous. Just we need to keep track of at the end of each block, what is the next block we want to look at. Okay, but that is for the given file. For each file, it has this list, each file. Most of the time, your file will fit into one block, but for each big file, you have this kind of a linked list, keeping track of what is the address of next block, and so on. So therefore, if you are looking for searching for something, you can look at this block, then go to this block, and then go to this block and so on. Right? So that is called what? Link file allocation. A linked list of these blocks which need to be contiguous, which need not be contiguous. It need not be physically next to each other. Need not. So therefore, it's logically sorted according to the linked list. Logically, not physically. Okay. And each block contains a pointer to the next block for that particular file. So that take only tiny storage because it just keep the block address of the next block. Okay. And final block, it will say something like null, saying that okay, this is the final block. You don't have to. There's no other way to go for this particular file. Okay. So therefore, this is for per file, right? We have sort of a linked list, so that we can go from one block to the other, navigate from one block to the other for a particular file. So this approach is good when you are searching for records, not reading the entire file, but searching for records. Maybe it is found in your first block or last block or in the middle. But usually we search, take one block, search in the memory, and then the other block search in the memory. So because each block has the address of the next block, of course, you need little bit of movements, arm movements, rotations, and so on to get into the next block. Right? But usually we don't consider it as a big go ahead if you are just searching for a particular record, not the entire file. Okay. So this is how you visualize it. Okay. So this is, say, file allocation table for one file called Jeep. So it just keep track of what is the start block, what is the end block. Right. So the start block according to this one. This is what your operating system keep track of for this particular file. Then for another particular file, there will be another. If you have 100 files, you have 100 such records. Say Jeep file, you start at the 9th block and ends in 25th block. So therefore, first, if you are searching for something, you first go to the 9th block. And if it is not there, what you are looking for, maybe a record is not there. Remember, this block has the address of the next block because it's linked. So maybe it will say next block is 16. Then you go to the load the 16 block and search. Still, if you don't find it, this block says the next block for this file is 1. So you go to the first block and search. Maybe you find it. So then that's the end of the story. Or you just keep going, and this block says, the 25th block says, and anyway, we know that it is the end block as well. So usually it will say the next block is something like -1 or some special character. So then we know that that is the end of the file. Either by looking at the block pointer there, or maybe your table has the end block number. So therefore, we know that there's nothing beyond 25th block for this file. Okay. So that is called link file allocation. So advantages are, we are not looking for contiguous blocks, right? Contiguous physical blocks. So therefore, we don't worry too much about fragmentation and so on when it comes to link file allocations. Okay. But at the same time, if you have a very big file, sometimes yes, you need to go from one block to the other block to the other block, and a lot of disk movements might be needed because they are not consecutive. Okay. And of course, very little extra storage is used, which is almost we can ignore. That is keeping track of the next block of code. That is very minimal, right? So that is not usually a big issue. Right. So that is link file allocation. So the third approach is index file allocation. So a lot of students get confused about link file and index file because it looks the same, but they are different, somewhat different. Okay, somewhat different. In index file allocation, there is something called index block. For each file, there's index block. And that index block has the index values for that file. Okay. So this is for a file called Jeep. It says index, it just keep track of what is the index block. That's all. Operating system just keep track of for each file, what is the index block. So then it loads the index block. So then it has pointers to more than one, possibly more than one blocks. In link, every block has a link to the one block, but here index block can have link to maybe 10, 20 blocks. So therefore, you go first when you are searching for something, maybe some records, you first load the index block and look at this index table. And then index table, you say, yes, if you are looking for this particular employee with this employee ID, you must load this particular block. And when you load that particular block, that record will be there. So that is what is by index block, index file allocation. So this approach is super useful, super efficient when you are searching for maybe one or two specific record. Because you first go to the index block, and index block has some ranges. Say in this range, go for that block, this especially for primary key related searches. And it knows that these ranges you must load that block and so on. So therefore, most of the time you just need to load in two blocks, index blocks, then the block containing your data. Okay. So in the databases, when you create index as part of your table, usually your database make sure that it use the index file allocation so that the search become fast. Okay. So this approach is not very efficient when you want to load the entire file. So then of course the contiguous is better. So this approach is not very efficient when you want to search sequentially from top to bottom, like sorted data. But this approach is index file allocation approach is super useful when you are just searching for a particular record, like student with student ID 350, that kind of a thing. So then you load this, and from your index table, you know that for this particular ID, you need to go to that particular block. Right? How to do that? We don't discuss in detail because that is little bit beyond your A-level ICT syllabus. And sometimes this index block can be kept in the memory because it's so frequently used by OS. Sometimes you, of course, in the disk also you have index block, but most of the time this index block is kept in the memory as long as you use that particular file. Again, index block per file, okay? Right. So those are the three type of file storage mechanisms. What are those? Contiguous file allocation, link file allocation, index file allocation. Okay. Right. So there are few more concepts related to file allocation. Let me check. There are few more concepts related to file handling and file allocation, which are important for your operating system. So operating system keep handle these things, so keep track of these things, so manage these things. An important concept when it comes to file handling is the concept called file control block. Now, if you see this word, especially in MCQs, or sometimes they have asked this in your structure also, you must know what is mean by file control block. So this is something like when you go to your file explorer or something and say right click and properties. So basically you are looking at some of the information from the file allocation, how do you call it? File control block. Basically, we are looking at not all the details about the file control block, some of the important things in the file control block for that file. Every file has separate file control block. So it includes what is the extension, what is the file name, what is the file size, what is the what is the last created date, last modified date, last access date, where the file is currently used, Is it a read-only file? So all those details are there in the file control block. Okay. So how do you call it? File control block. So we just look at the file control block when you just take the properties. Okay. But file control block is internal data structure used by your operating system. So it typically contains, of course, the details may depends on the what is your operating system is, and whether it's Linux or Windows or Mac or something like that. But the concept is there. So definitely it contains the file name and extension. So they have even asked in the structured paper what are the possible things, details available in file control box. So you can say file name and extension, total file size, sometimes even file record length, how big one record, if it is a data file, obviously, right? Record number of current section, last modified date and time, right? Whether file is open, closed, locked. So those details can be available in a file control block. Exact details depends on the OS. Right. So then we have different file systems. Different file systems. So the two commonly used file systems or most popular file systems are FAT system and NTFS. If you are using Windows, most probably what you use is NTFS. But if you are using pen drive or something, mostly those are FAT. And Linux also heavily use FAT. So FAT or NTFS is nothing to do with the hardware. So that is how strong. Remember, when you take a disk or something, we format it. So once you format it only, it is usable. So basically, when you format, we decide whether we format using FAT format or NTFS format. Okay. So at any time, you can reformat into a different file format, file system format. Okay. But for Windows, at least your system drive is default to NTFS, because NTFS is the Windows preferred approach, right? For example, you can see here, I have C and D drives. If I take C and take properties, and it says NTFS, you can see it's use NTFS file system. So most probably my D drive is also using NTFS because I just kept the default. Yes, it is also NTFS. Okay. So let me fix a pen drive. Just give me 1 minute to insert a pen drive. Right, now I fixed a pen drive as well. So now you can see it is E. Now let's see what is the file allocation system properties. And you can see it's FAT32. So that is my pen drive. So FAT32 is sort of a default in Linux and other operating systems. So why my pen drive is used in FAT? Because there's a high chance that I take this pen drive to another computer, which is not Windows. So therefore, portability wise, if you want to use a particular disk in different OSs, multiple OS environments, prefer to use FAT32. But if your disk is sort of a dedicated for Windows, go for NTFS, because NTFS is optimized for Windows. Okay, so that is the idea. So those are the small things you must know. Okay, so NTFS is sort of a default and optimized for Windows, but it doesn't it is not fully supported by other OSs. Right? For example, if I take a NTFS disk and fit into a machine with Linux operating system, it can read data, but it can't write to that file system. But if it is a FAT32, my Linux operating system can read and write. Right. So that is called what? File allocation or file system, not file allocation, file systems. So basically, it is something that is we need to specify at formatting. Okay. So let me again fix it. Okay, let me fix that pen drive again. Okay, I'm just looking for my pen drive. I just fix it again. Now again, you can see the E drive. If I want to format it, format it. Now here you can see it asks which file system you want, whether you need NTFS or FAT. You can see FAT is the default. Of course, I can use NTFS, which is optimized for Windows. Then I cannot use this pen drive in a Linux environment. So therefore, by default, when you insert a pen drive or something, even in the Windows environment, they format it according to FAT format, FAT file allocation. Okay. Right. So I don't want to format it anyway. And that is how it works. Okay. So the FAT versus NTFS. So you must know these things. So FAT stand for file allocation table. That was also originally developed by Microsoft, but now Microsoft has developed a different approach called NTFS. So therefore, though Microsoft developed FAT32, now FAT32 is predominantly used by other operating systems, whereas Microsoft has moved to NTFS. Okay. So it is supported by almost all the OSs like Windows, Linux, Mac. But it has some limited file size. Right? Limited file size for allocations. So therefore, we use FAT32 mostly for removable storage devices. So NTFS stands for New Technology File System, which has become the default format from Windows 7 onwards for Windows machines. And it is much more efficient and there's no minimum partition size. Okay. But the disadvantage is it may not compatible with other operating systems. Okay. So therefore, NTFS is pretty much used for your Windows system disk. Windows system disk, because it is optimized for Windows. So this is again sort of a one-to-one comparison between FAT and NTFS. Okay. Right. I already explained you the disk defragmentation. Right. You can see this is, say, for the same file, the file is now here and there. Right. In different blocks all over the disk. But after defragmentation, there's a possibility that they are in sort of a contiguous. Of course, if this is single thing, otherwise contiguous means not this, maybe this one and the relevant block in the other disk and other disk. But for visual effect, we have shown it like this. Okay, but definitely it has been reorganized. Okay, reorganized so that accessing file is faster. Okay, right. So that's it about file handling. Especially, you need to remember, understand what is contiguous allocation, link allocation, and index allocation. That is the most important part. Okay. Right. So next time we'll do process handling. Right. And also we'll do some past paper questions, because process handling is relatively small, but there are big diagrams like process goes from this to that and so on. Okay, maybe before process handling, we need to do memory handling, because we need a little bit of understanding about memory handling to properly understand process handling as well. Okay, so which one is in your second? Yeah, we can do the process handling and then come back to memory handling, because memory handling is the toughest topic. So therefore, we will take it to the last. Okay, we will take this to the last. Right. So we stop at this point. So next time, we will do the process management. Okay, and possibly some past paper questions. Right. Thank you.
Thank you, sir. Have a nice day, sir.
Okay, you're welcome. Have a nice day.